Hi, this is Ramya, and I'm saying about set theory. Set. A set is a well-defined collection of distinct objects or elements. Sets are usually denoted by capital letters, capital A, capital B, capital C, and elements by lowercase letters, small b, small c, and so on. For example, A set consists of 1, 2, 3, 4. These are set of natural numbers less than 5 and consist of B apple, banana, mango. These are set of roots. Finite set is set that contains a limited or countable number of elements. Example, C equals to 2, 4, 6, 8, 10, and D equals to Monday, Tuesday, Wednesday. Infinite set is set that contains an unlimited or uncountable number of elements. Example equals to 1, 2, 3, 4, 4, and so on. These are set of all natural numbers. F equals to x belongs to all and x greater than 0. These are set of all positive real numbers. Equal sets. Two sets A and B are said to be equal. They contain exactly the same elements regardless the order. For example, A equals to 1 to 3 and B equals to 3 to 1. A equals to B. They contain the same subset. A set A is a subset of B if every element of A is also called as element of B. For example, A equals to 1, 1, 2, and B equals to 1, 2, 3, 4. We can say that A is a subset of B, and the elements of A are consisting the elements of B. And note point. Every element of every set is a subset of itself. The empty set is a subset of every set. Null set or empty set. A set that has no elements is denoted by flower brackets or 5. Example, A equals to 5 since no such even number exists. Disjoint sets or mutually exclusive sets. Two sets are disjoint if they have no elements in common. Example, A equals to 1, 2, 3 and B consists of 4, 5, 6. A intersection B equals to 5. We can say that there are no common elements in A and B, so they are disjoint. Universal set is represented as U. The universal set consists of all possible elements in consideration, usually defined by contents. Example, if we are discussing natural numbers less than 7 or less than 10, U equals to set of 1, 2, 3, 4, 5, 6, 7, 8, and 9. If A equals to 2, 4 and B equals to 1, 3, 5, and we can say that A subset of U and B subset of U. Here is the conclusion of sets, set, finite set, infinite set, equal set, subset, empty set, disjoint sets, and universal sets, and the symbol or notations and the example which we are discussed before. And set operation. A set operation combines or compares sets to produce another set. The major operations are union, intersection, difference, complement, union, and intersection of enzymes. Union it is represented as union B, intersection is represented as intersection B, and difference is represented as A minus B, and complement is represented as A bar, and union and intersection of insect we can neglect it here. Union A union B. Definition. The union of two sets A and B is a set containing all elements that are in A, in B, or in both. Notation. A union B equals to X such that X belongs to A or X belongs to B. Example. A consists of 1, 2, 3, and B consists of elements 3, 4, 5. And A union B equals to 1, 2, 3, 4, 5. And here is the Venn diagram of A union B and intersection. And it is represented as A intersection B. Definition. The intersection of two sets A and B is a set containing elements that are in common to both A and B. In notation, A intersection B equals to flower brackets of X such that X belongs to A and X belongs to B. Example, A equals to 1, 2, 3, and B consists of 3, 4, 5, and A intersection B, which are common to both sets, that is element 3. And here is the Venn diagram of intersection of A and B. Here we can see the common elements which are in A and B difference, and it is denoted as A minus B. Definition: the difference A minus B is a set of elements that are in A but not in B. And notation: A minus B equals to X such that X belongs to A and X does not belongs to B. Example: A equals to 1, 2, 3, B equals to 3, 4, 5. A minus B equals to 1 and 2. Here we are neglecting the elements which are common in A and B, so we can get the difference of A minus B. In complement, and it is represented as A bar. Definition: the complement of a set is a set of elements in the universal set U that are not in A. Notation: A bar equals to X belongs to U. Mm, X does not belongs to A. Example: U equals to 1, 2, 3, 4, 5, and A equals to 1, 2, or 2, 3. A bar equals to 1, 4, 5. And here is the Venn diagram of complement of A bar. Union of n sets, A1 union, A2 union, and so on up to A. Definition: the union of n set is a set containing all elements that belongs to at least one of these sets. Notation: A1 union, A2 union, and so on up to A. And flower brackets open X such that X belongs to A for at least one. I belongs to 1, 2, 3, and so on up to N. Example: A consists of 1, 2, and B consists of 2, 3. C consists of 3, 4. A union B union C equals to 1, 2, 3, 4. And intersection of n sets. A1 intersection A2 intersection A3 and so on up to A. In the definition: the intersection of n set consisting all only the elements that are in common to all sets. Notation: A1 intersection A2 and so on up to AN. And big flower brackets open X such that X belongs to AI for all I values are represented as 1, 2, 3, and so on. Example: A consists of 1, 2, 3, B consists of 2, 3, 4, C consists of 3, 5, and A intersection B intersection C equals to 3. Law of sets. There are 8 types of sets. They are idempotent laws, domination laws, identity laws, complement laws, commutative laws, associative laws, distributive laws, and last, De Morgan's laws. Idempotent laws. A union A equals to A and A intersection A equals to A. We can say that the element which consists of a union or intersection, then we get the same element. Second one, domination laws or null laws. A union U equals to U and A intersection phi equals to phi. A union U equals to U. We know that A is a subset of U. There is no the elements which are in U that the elements of A. And A intersection phi equals to phi. We know that null set consists of no elements and the common elements of A and phi is phi. Identity laws. A union phi equals to A. A intersection U equals to A. Complement laws. A union A bar equals to universal set and A intersection A bar equals to phi. Commutative laws. A union B equals to B union of A and A intersection B equals to B intersection of A. Associative laws. A union B union of C equals to A union of B union C. A intersection B intersection C equals to A intersection of B intersection C. Distributive laws. A union of B intersection of C equals to A union B intersection of A union C. A intersection of B union C equals to A intersection of B union A intersection of C. And last, De Morgan's law. A union B full bar equals to A intersection A bar union intersection of B bar. A intersection of B whole bar equals to A bar union of B bar. Here in De Morgan's, we can observe that the bar A union of B whole bar is divided as A is divided as A bar and B is as B bar, and universal set uh, is represented as intersection. This is about De Morgan's law.